Alright guys, I'm back to my second part of special factoring. The first I talked about difference of squares only, and I touched on it. I said basically if you can find the square root of two terms that are being subtracted, then chances are they're difference of two squares, and the formula for that in factored form is a squared minus b squared is the same as saying a minus b times a plus b. So that's one formula for difference of square, and I have a video on difference of square. Something I want to bring to your attention to when dealing with difference of square. Basically, if like I said, if you can find the square root of both terms, when it comes to numbers, so let's say for example you have x to the x squared minus 25, right? So I could find the square root of x squared and the square root of 25, and the square root of x squared is x. And how do I know that? So basically what a square root is really saying x squared to the half. That's what a root is. It's a fraction of a power. That's what roots are, where the numerator the denominator actually tells you the root of your problem. Okay, so for example, if I actually find the cube root of 8, right? This is same as saying it's 8 to the 1/3, right? Where the denominator tells you the root of your base, and basically the numerator tells you how many factors of the base you have. So I have one factor of 8, and it's a cube root of 8, one factor of the base. And in this case, I have one factor of x squared. Okay, so now if I was to multiply x, because the rules of exponent, if you look at my videos on the rules of exponents, it say whenever you have a power raised to another power, you times the powers. So this is actually saying x to the 2 times a half, and you see they cancel, you get x. So that's how you know the square root of x squared is x. Also, another secret is if your power is divisible by 2, then you can find the square root of your power, and this here is 5, right? Because this is just a constant term. Just simply means that if you find a factor times itself, usually the square of it is also, you can find the square root of a number. I'm not sure if I'm saying that correctly. Forgive me, guys. I just woke up and trying to get this done to you as soon as possible. But anyway, so this would be actually x minus 5 and x plus 5. And it's commutative, of course, because it's multiplication. So whether you put x minus 5 or x plus 5 and x minus 5, it will yield the same result. So for example, now let's try one where the power is higher than 2, right? So let's see, it's x to the 4th minus y to the 4th. So I said one way you can look at it is either if you can find the square root of both terms, or if your exponent is divisible by 2. So if your exponent is divisible by 2, it basically gives you a hint of what your a would be and what your b would be. Ha ha. Sound like a little tongue twister there. So this is really square root of x4 is x squared, and the square root of y4 is y square, right? And when I say y4, x4 is y to the 4th power. I'm just explaining it in layman terms. So this now is x squared minus y squared times x squared plus y squared. Now bear in mind that when you're factoring, you should factor completely. So it's almost like when you're reducing fractions. Okay, you got to reduce it to the simplest term. So this is not factored completely because here you still have a difference of squares. So watch out for questions like those. They're very tricky. Students would usually just stop up to here and go away smiling, thinking they've done something great. But here, this is still factorable. And by now, this would be, you should get the formula here. This would be x minus y times x plus y. And don't forget our other factor term, factor that we had up here. It's not a term because we're not adding or subtracting. And remember that we said that we cannot factor sums of squares. And I proved that in the video when I was talking about factoring difference of square. So this is a little expansion on the difference of square and understanding square roots more and how they are similar to exponents and how you get your solution. Now, there are also two other types of special factor, and there are difference of cubes, right? Which meaning that you simply have two, and it's usually two terms, right? You have two terms that you can find the cube root of. And once you identify that the two terms, it's a difference, you can find the cube root of it. Here's the formula that goes with it, and this calls for a little more memory. So for the difference of cubes, you have a formula. It's a minus b times a squared plus ab plus b squared. So you got to pay attention and make note of that formula. And when we're dealing with sums of cubes, so unlike sums of squares are not factorable, sums of cubes are factorable. And here's the formula for sums of cubes. That's a plus b the factor a plus b times the factor a squared minus b squared plus minus ab plus b squared. And I kind of give them little acronyms, like difference of square is DOS, difference of cubes is DOC, and sums of cubes is SOC, in case I want to just use short language when I'm working on it. Now, the difference of square is pretty much easy to remember because I think most of us probably could remember from learning this from high school or somewhere in a past life, right? So, but the sums of cubes and the difference of cubes, just call for a little more wit. So what you got to remember with difference of cubes and sums of cubes is the first factor will always take the sign of the original factor term, okay? So here it's a difference, so the first factor is a minus b. Here is a sum, so the first factor is a plus b, okay? And it's kind of weird. You might find this trip you up a little bit. Is that with the difference of cubes, the next factor are all sums, right? A squared plus ab plus b squared. But with the sums of cube, the next factor is a combination of difference and sum. So that way, when you do the distribution, you actually get rid of the difference and you just end up with sum. So these you have to gonna commit to memory, and then it's just a matter of plug and play. All right, so let's do some examples. So here we have x cubed plus 125, and this is one of those obvious numbers, so clearly we could find the cube root of each term, and it's a sum. So we're actually working here with sums of cubes, sum of cubes, right? SOC. Okay, and if we commit it to memory, we know that our sums of cube, right, or a cubed plus b cubed is, I get a hint of what my first factor will be. So that's a plus b. And then my next factor would be a squared minus ab plus b squared. Remember, sums of cube is what have the difference term in the next factor. So now I just got to find my a and find my b, and then I just got to plug in. So here we go. So I can find the cube root of x cubed, because also if my exponent is divisible by 3, I know I can find the cube root of it. So the 3 divide 3, I'm left with one factor of x, and the cube root of 125 is actually 5. 5 times 5 times 5 is 125. So here I have my a, and here I have my b, so then I'll just plug in. So now this would be x plus 5 times, what's my a? My a is x, so that would be x squared minus ab, so that's 5. My b is 5, so that's 5x minus 5x, right? Plus b squared. Now my b is 5, so b5 squared is 25. And that's my solution. Nice, beautiful. Once you could commit the formula to memory, it's beautiful. Great, so here we are. Now it appears as though we have two terms, and the first term is an x cubed. So chances are there's probably a factor in here if we times it by itself 3 times, that we'll get 216. So definitely I can bet that we can find the cube root of both x cubed and 216. Now notice this is a difference of cubes. Difference of cubes, DOC. And remember the formula for difference of cubes. If we commit to memory, we know that our first factor will take the sign of our original term. So this would be a minus b. And then we know that the remaining factors are all sums. So this is a squared plus ab plus b squared. Beautiful. So now I just got to find my AB in this expression over here. So, you know, I know that, so this is divisible by 3. As I said, that could be one way of knowing, finding the cube root of it. But just take it. Oh, and by the way, guys, it's supposed to indicate that this is a cube root. If not, people would think it's a square root. Any root above 2, you have to indicate it at the side. Okay, and make sure it's written really small so as not to be mistaken as a factor, as 3 times the square root of something. For example, like this is 3 times the square root of 216, right? And this is versus this, which is the cube root of 216. You see how they're written differently? Okay. All right. So I am pretty much familiar with 216. These are like popular numbers. And I know that if I cube 6, that I will get 216. But let's say you weren't aware of that. And let's say on the exam, you were not allowed to use a calculator. So here is how I kind of figure out my numbers. I usually take them and break them up into prime factors and then manipulate this. So I'm looking at 216 and I'm looking like, that looks like a 21 and that looks like a 6 and it looks like 3 can go into this number. Okay. Also, another way if you know this number is divisible by 3 is if it's sum. There's a video on division test. Did I do that? No, maybe I haven't. But there's a division test saying that if you want to know a number is divisible by 3, just sum all the digits. And if it's divisible by 3, then it's divisible by 3. And 2 plus 1 plus 6 is 9. And 9 is divisible by 3. Anyway, if I looked at this, I can see that 3 can go into 21 7 times. Right? So 3 is my divisor. And 3 can go into 6 2 times. So 3 times 72 is actually 216. And I know I can break down, so 3 is already prime. So I can break down my 72 into 2 more factors, 8 times 9, right? And I'll break, these are still composite, but I'll break these down into prime, right? Now, it might be a long process, but at least you'll get the answer right. And once you're used to breaking down numbers or prime factor number, you'll probably do it faster than someone stopping to think, what factor times itself 3 times will give me 216. So here you got to be a little witty with this. And it's only because I'm experienced with numbers. That's why. So I'm looking at, I have 3 factors of 2 and I have 3 factors of 3. So it looks like I have 3 factors, potentially 3 factors of the same number that will give me 216. So I'm looking at 3 times 2 is 6. So I got 1 factor here, right? I'm looking at another 3 times 2 to give me 6. So I got another factor here of 6. And I'm looking at another factor, 3 times 2 is 6. So like, I got 3 factors of 6 that will equal 216. So bam. Here we go. I found 6. I found my A and I found my B. So now I'm just going to plug it into my formula. So this is x minus 6 times x squared plus AB. So, you know, that's 6x. And B squared is 36. Beautiful. Okay. So just, we could probably just do one more problem. Let's do a problem where they get a little witty with things. So let's take a look at, for example, let's take a look at this example where it's number 7. Taking a look at number 7. So that's actually 2 to x to the 5th power minus 16x squared. Now, the secret is you're looking at this and like, that doesn't look like a difference of square. Neither does it look like a difference of cubes. Well, let's see. Always check to see if you can factor initially. And I think I mentioned this in one of our videos on factoring. So if I take a look at this, here we go. I can see that these 2 terms has a common factor of 2. And I can actually factor out an x squared, because they both share. So I can find a GCF of 2x squared here, right? 2x square. And please look at my, by the time you get to this video, you should be versed in some concept of factoring. If not, I suggest that you go back. This shouldn't be the first time that you're seeing factoring and just jumping straight to special factoring. So here we go. My GCF is 2x squared. What am I left with? If I divide my GCF by 2x squared, I can see my remaining factor. So the 2's cancel. And in the rules of exponents, when they have the same base, you subtract power when dividing. So that's x cubed. And guess what I'm left with? Minus 8. Minus 8. Ha! This looks like a difference of cube to me. So let's go for it. So that's x, if I find divide this by 3 or find the cube root of x. And we know by experience that the cube root of 8 is 2. Right? So here's my a and here's my b. And not to forget my original factor. So here I have 2x squared. And now I have my x minus b. Right? My a minus b, I should say. So that would be x minus 2 times x squared. Plus, remember, for difference of cubes, the first factor is a difference, but the other factors are all sums. So AB, 2a, 2x, plus b squared, 4, right? 2 squared is 4. So all of this is included in my solution. Okay, guys, give the problems a try in your text. And if you have any questions or concerns, you know how to find me.